Okay, this is about performance in NativeScript. I'm not going to go into Webpack because they dealt with that this morning, which I'm assuming everybody knows you need to do this with Angular app. What I am going to deal with is basic JavaScript performance. This really affects Angular, Web, and NativeScript. The first thing is, now the demo gods will be with me. Why did I go down? That's nice. Okay. Let's dive into the performance issues. The one thing about most JavaScript is everything runs on the one thread, the main thread. It's the same in the web. It's the same on NativeScript. React Native actually has two threads, but you're running on a background thread by default. With NativeScript, everything runs on the main UI thread. The reason for that is because it allows you to have access to the UI components, because by default, both iOS and iOS and Android require that all of your UI, your GUI stuff, is on the main thread. And so for simplicity, NativeScript also uses the main thread for everything. And so that can cause you performance issues if you guys have noticed where your application will do things like this. You see my little N there? It kind of freezes because the main thread is doing something. And so unfortunately, it is unable to maintain the animation while that thread is busy. The next issue I want to deal with is layouts, which Brad actually covered a lot, but I'm going to go into a little bit more about it. Just one small segment that I wanted to touch. And then I wanted to deal with the functions and objects inside loops. This is something that even gets me, and I know better. It's very easy to make this mistake. And then I want to deal with some statements like the debugger statement eval with, which can cause issues at least on Android. They don't cause issues so much on iOS because iOS is purely interpreted. It does not have any type of JIT or compilers, where V8 on Android actually compiles your code into a optimizable code, but if you use these type of keywords, it won't. And that makes a big performance difference on Android, where iOS, it doesn't really matter. And then how to access the native information to get actually information out of the engine, what's going on. Because this can actually help you figure out, oh, why is this not working? And then object class modifications is another area where performance can have an issue. Okay, so as I mentioned earlier, everything runs on one thread. It does make it really easy to deal with all the GUI stuff. So when we bring in new plugins, that's the reason why plugins on NativeScript are so simple, because everything's running on the main thread. When you do something in React, it is much more complicated because the GUI is on its own thread, so you have to write all these wrapper stuff to be able to talk to it to handle the data transactions between it. The easy thing is it just so simple. The bad thing is like I mentioned, is the jank. You can easily do something performant or you can cause it to be imperformant on your application when it's loading things, when it's pulling resources, loading data from the database, like the SQLite button does here. It actually goes and hits the SQLite database, pulls some records, and you see it have a glitch there. And your customers will notice that if all of a sudden they're clicking a button and the app's not responding. One of the ways to solve this is to actually use the cool web workers. NativeScript actually offers workers in it, and they built it to be pretty much identical API as what you're used to in the web browser. When you do that, you'll see that the N does not stop when I do any of those things, because that same code, I just told it to run inside the web worker instead, and it sends back the results of how long it took. That's what the number, by the way. The SQLite is 312 milliseconds that it ran. And the loops was 20 and 3 seconds. Because it's running inside the worker, your main API you don't see any glitches like that. So when you can, try to run any of your heavy processing, including your data hits and anything reading files, as much as possible inside a worker. One caution here is you only want one worker. You do not want to be creating more than one worker, because each worker is its own full NativeScript engine. And so you can run your phone out of memory really quick if you decide, I'm going to start 5 workers because I want to make sure everything's performant. Typically, you're probably only going to want one worker because of that particular thing about memory. And you want to, if you're worried about older devices, that is a limitation. You want to make sure that you keep yourselves in with your main thread and one worker thread, and then you just send messages to your worker thread to do whatever. Most plugins, like the SQLite one I did in this demo, I just imported it just like I would in normal code and ran my code, and then you send the message back with your data. And the message passing between the threads is pretty darn quick. The Android development team did a really good job. Nested layouts. What Brad talked about a little bit earlier about nested layouts is more of an issue on Android than it is on iOS. This is another one of those Android-isms. This issue actually affects native apps too. I mean, pure Java apps. I mean, you will see where the developers at Google will tell you, your problem is your layout's too complex. You have too many sub-layouts. Because every single one of these layouts has to be rendered in size, and it calculates all the way up to all the way out to the main frame what size each piece is. And so that takes time. And that is a cost on iOS, but the way iOS renders its stuff is differently the way Android does. And so the cost on Android is a lot more complicated. This example here is I created a stack layout, and I'm showing you how many stack layouts I had to use to generate the exact same thing in a grid layout. There's the red one, which is the outer one that contains everything in it. Then there's a green one, which is the first line of your two things. Then there's a blue one, which has line 1, line 2 in it. And then there's the orange one, or yellow, that has the next set. And then we get out of that stack layout and we go to the purple group, which then is, again, another horizontal group. And you have line 1, line 2, line 3. And so by the time you're all done, you have 7 or 8 stack layouts. And so it has to calculate every single one of these inner stack layouts before it can calculate the outer stack layout. And so it grows in time of how much time. And then I put right below it what it would look like in normal terms without all my borders, so you can see all the things. And then I show you a grid layout. They look identical. The code is very similar. The only difference is that the grid layout has only one rendering pass. It's able to use all the information from the labels and what information you give it to be able to detect what size it needs to do. And so you end up losing a lot of cost there. You don't have that cost to pay to render every one of those stack layouts. So this is my code for the stack layout class, and you'll see that I put borders around every single one of these things. And it's not terribly complex, but it is what you see in a lot of applications. You know, people do, stack layout, then we put in our stack layout for our horizontal, then we stack layout the pieces inside that. And so this is a very common pattern you see. And then this is the code for the grid layout. It does take a little bit more thought. There's part of the reason why I colored it is because what you need to do when you deal with a grid layout and you're trying to emulate something you do with a stack layout, and sometimes I will actually draw it out first in a stack layout, I'll build my thing. You figure out what your common denominator is. So in this case, I have 3 and 2. So the common denominator is 6, between the two of them. So that way I create this with 6 stars, saying I want equal space 6 ways. And then I use column spans to tell it where to place these items. And so that's how I was able to make the first one. I'm saying we're putting line 1 on row 0, which is the first row, and it takes 2 spots. And then the next line is row 1. So this is row 0, and this is row 1. And so that's all I'm doing is I'm just laying out each piece on the thing. And so you kind of have to visualize that in your mind, how the stack layout versus grid. But this is way more performant. I've taken an app that was taking over a second to navigate to another screen and dropped it to under 100 milliseconds. And it really was because of so many stack layouts. And just switching it to 1 or 2 grid layouts made the difference. I mean, that was really it. Every one of the stack layouts has to generate not only the code that goes through the Android side of things, but the JavaScript code to instantiate the new object that tracks the stack layout through the JavaScript side. So you have all that additional code that's running on the JavaScript side and the additional code on the Java side. So that's the one thing I wanted to point out about layouts, grid layouts versus stack. Your app will be a lot more performant if you use the fewer layouts you can. Loops. Now this, I noticed, I do this myself all the time. every object in JavaScript creates memory usage. Now, most of us don't think about it because the GC will kick in and clear it out. But you might notice sometimes when you're navigating between pages or you do something, all of a sudden the application just freezes. Well, one of the things that most people don't think about, and you'll see that I have down here highlighted in red, this little function. Every single loop that this is doing, it creates a new function there. So by the time this loop is done, it has created 100,000 functions in memory. That means that it has to process that code every time, and it has to generate all the memory for every one of those things. And then once it finally figures out, oh, I'm done with these, I can GC it, then it has to empty it. So you need to think about when you're doing loops about any object creation or any functions, because I mean this pattern right here where you just toss a function into it as to have it do it is very common. You don't even think about it. But if it's going to be in something that's looping, you want to make sure that you do something more like this, where you create the function outside the loop and you pass that function. You create the function out here and then you pass the function in the loop. So that way you create the function once and then you're running the function 100,000 times. And you'll notice in this demo, when I click the loops, the first one is 3.63 seconds, and the second one is 17.54. That's the difference between it having to create that 100,000 times, and this is on a fast machine, this is not on your slower phones, versus keeping outside the loop. So that is one of those things you need to take into account, and that's a big thing is objects and functions that you create. Anything you create inside a loop will be destroyed typically outside the loop. And if you keep creating it, you're wasting your time, you're wasting the GC's time, and you're probably going to be adding jank to your application. Like when I had the workers off, you'll see the difference. I mean, it's noticeable. So the next piece I wanted to deal with was enabling optimization testing. This doesn't apply to iOS. Unfortunately, JavaScript core, which is what iOS uses, doesn't have a lot of these internal hooks. V8 has a huge number of hooks to tie into. And you can do this on Chrome, and you can do this actually in any V8 type engine like Node and whatever. There is a command line called allow native syntax. And what that does is that turns on your ability to talk to the back end part of the JavaScript engine and pull stats out of it. It'll give you all sorts of stats. There is an open source project called V8 Natives, which kind of wraps up the most common of those features that I actually wrote about 6 years ago, I think, for Node and Chrome, because I was doing a lot of testing there. And what it does is it gives you functionality that allows you to just call a simple function and it returns the pieces of information. And if you forget to put this command line in, it doesn't crash. Because this command line is very important because those calls that you do, if you don't have a command line in, those calls actually crash your application immediately. And so the V8 Natives is kind of a wrapper so that you wouldn't have to crash it if you're trying to put it into production. It's smart enough to know, oh, you don't have this ability. So what you do is you open up the app.js file that is inside your app folder, and you'll always see in it there's the exposed GC because it's one of the flags that NativeScript uses to get access to the GC variable. And you just add this allow native syntax. And then it gives you functions that allow you to get like the heap usage, what's going on with memory. It gives you the ability to take a JavaScript function that you're running and tell it to de-optimize the function and then have it re-optimize the function. And you can actually say, is this function optimizable? And it will actually run the function several times through its optimization system and verify that the optimization, it can be optimized or it won't be optimized, which is very useful if you're finding that you're seeing this performance hit. You can say, I would like to check the optimization of it. So I'll show you some code. This is really, oops, that's giving me back the information. I'm saying test the optimization of this function, and what I'm doing is I'm throwing in a function here. But I had more earlier, but I decided to shorten it down. And it just runs this test optimization, it tosses it over here, and so when I click this button, you'll see it says debugger unoptimized, add unoptimized, and I'm going to show you why those are unoptimized. But it throws a function in, the V8 engines, both crankshaft and turbo, all of them attempt to optimize it and will report back the value, whether it was optimizable, which engine optimized it in some cases. And so that way you know, hey, this code works, or no, this code did not optimize, which is, depending on your code, could be a big thing. Depending on what performance area you're working on, it could be a major thing. So the V8 natives, it's not a plugin, it's a node module, but you can just do an npm install and it works out of the box in your NativeScript app now. I've fixed the things, little minor things that wouldn't work in NativeScript today. And so you can just run the test optimization on any function or a group of functions, because if you know one function calls this function, which calls this function, you can put all three of them in there, and then it'll report back on all three of them which one of them was optimized, which ones was not optimizable, and we'll give you that information back. As to unoptimizable code, I'm going to show you two examples of code that will not be optimized. If you have the debugger statement anywhere in your function, it doesn't matter if the function's 4 lines like this one or 100 lines. If there is a debugger statement, even if it's special case with a false where you can't even get access to it, if the debugger statement exists in there, it will not optimize it. It detects that and it will throw the thing out and it'll always stay unoptimized. So if you are doing debugging work on your thing and you have this neat little flag, if in not production, your beta mode, run the debugger flag so that you pop up your editor, your debugger, well, that is going to cause that function to always be unoptimized. It will never do it. So if you want to do that, you want to actually drop that flag into a sub-function and then call that sub-function, because it'll optimize the parent function and it's able to optimize everything else. It just, any function that has it in there won't be able to. So you could do like this, where if production, or if not production, then debugger, and then you could literally go through all your code and just use the debugger function, and it would, the function I have here, and it would work. Because that little tiny function wouldn't be optimized, but the rest of your code would be. The other thing that sometimes gets people is the polymorphic functions. This add function is very simple. You take x and y and you add them together and you return the value. When you throw in add 10, 20, it goes through and says, ooh, cool, these are integer. I can do that. And it optimizes the function and it turns it into a really quick function in whatever binary format it does, the engine that it's using doesn't. When it hits the second statement, it goes, oh wait, this is a string. I don't know how to handle a string. So then it automatically calls back into the engine and says, you need to de-optimize this function. And it drops it out. And so all of a sudden, this add function is no longer optimized and no longer will be optimized throughout the rest of your program, just because you passed in a different type. That's one of those things that you do need to worry about with TypeScript, even, because if you use the any keyword or use the pipe to say it can take this function or this type, when you pass in a different type to it, that automatically causes it to get pushed out of the ability for it to be optimized. And depending on, again, on your phone, your function, that could be a major hit, because optimized code is tremendously faster than the interpreted code in the V8 engine. And there are several other examples like that, but those are the two big ones that hit people. The last piece that I really wanted to cover was object changes. And this is a pattern that hits me frequently, and I have to fix it all the time. And it's even, unfortunately, littered in the TNS source code. It's very easy to do because you don't think about it. When it creates this my class, and I'm taking code that was generated by TypeScript, basically, other than it's handwritten, and I do this dot high or underscore high equals hello, it goes, I'm creating an object. Awesome. Okay, so it creates this object in memory and says, I have a high pointer to it. And so it knows that this is a class. Later on, when you call this .NativeScript on that object, and it adds this underscore NativeScript to the class, all of a sudden, V8 goes, whoa, this is not the same object. This is a different object. So it actually has to copy the original object and all of its memory to a new spot in V8. and then assign the NativeScript flag to it. So now you actually have two objects in memory. You have the original design, which this underscore hi, and now you have the second one with this hi and this underscore NativeScript. And those will remain until it decides that it needs to GC them out. And so you can waste a tremendous amount of memory because you have different classes later on that add a new value into this part of it. So what you want to do is you always want to define every single one of your variables that you're going to assign into as part of this in the function constructor. When the function constructor is generated and it generates all those things, then V8's able to go, okay, so this is what it looks like. So then later on, when you hit this NativeScript and it goes underscore native, oh, this matches my object, so I'll just put it in there. And so you end up with much more optimized code, and you don't waste as much memory because you're not generating multiple copies of this object in memory for it to figure out which one you might be using at that time. Even though you know you're never going to go back to the original one, V8 doesn't. And so until it's able to optimize it out, or you run the GC, you've wasted a tremendous amount of memory. Do you guys have any questions? I've tried to cover some of the basics that can hit you in most of these applications. Sure.
Speaking of workers, what can you pass to and from a worker?
The question is what can you pass to and from a worker? You can pass pretty much everything. The only thing that's limited is you can't really pass like a GUI object. An object, a pointer to, like, say you got the DOM object so you could change the label. You can't pass that through because, again, the GUI has to stay on thread 1. But for the most part, it serializes it through JSON to the other side. If you have some structure that can't be serialized to JSON, it won't go. But most of the time, you can pass almost any type of data. I've passed, I have an app that I've passed like 3 megabytes of data through it, and it's almost instant. I mean, Peter did a great job. I think Peter's the one who worked on that part. He did an awesome job in the performance of that. So.
But it's still serialized through the process. But it's still, oh my God. It's still serialized for the process, so if you pass in the instance of an object, like a class instance, it won't go through, right?
My understanding is it is serialized and it does go through. I have passed all sorts of things through it, and I've never run into an issue other than the, again, anything that's dealing with a pointer to a native GUI object, or a weird class that has recursion, because then the JSON parser, can't really figure out how to actually compress it into a text, because it really does basically that, to my knowledge. And I could be wrong. Peter may have a different optimization there, but my understanding is it turns it to JSON object and brings it over the line and undoes it for you, and so you have it there. But it's extremely performant.
Thank you.
Any other questions?
Do you mind to show the call to the worker?
Sure. Okay, so on my main page, my run tests basically looks at that little switch here, say whether it's on or off. If it's on, then it just says worker post message and sends it basically which test I want it to run, because every one of these is basically run test, whatever one I want it to. So in this case, it does this post message and sends me the test over the board. Otherwise, it requires that file and then runs the test, and actually sets up the post message so like it was pretending like it's a worker. So that way I don't have to write multiple branches of code. The worker is worker handler. It's really simple. Basically on this side, what I did was, actually I don't even need this call anymore. That can go. I got the message. I get the message on the on message. I look at the message data require, what was being passed to it, and then I just require that from the worker side, and then say, hey, this thing, run my tests. And that, each of the run tests, the tests themselves, when they're all done, they use the post message, which is normally how you communicate back from the worker back to the main thread. They use the post message to send me back the results to my main thread. And so that's really fairly simple. I mean, that's how I did it. Any other questions? Sure.
Are the workers equally performant on iOS and Android, or is this an Android specific?
As far as I know, iOS is just as performant. I've used it on both. That some of these things I dealt with was really Android specific because of the V8 engine. iOS has no jitting because NativeScript had to be able to call into the native runtime stuff, so they weren't able to use the jitting. That's something Apple required. I'm sure they would love to be able to use the jitter, but they can't because of Apple. So Apple, on the Apple side, everything's interpreted. It doesn't matter. There's nothing like that. So some of this stuff doesn't really matter on Apple side. And the other thing is JavaScript core doesn't actually expose some of this stuff. The V8 engine is very exposes so much data. The couple calls I showed here is a very small number of the calls that the V8 natives has, and the V8 natives library that I wrote is a very small number of the actual real number of calls that you can actually get information from V8 for. Any other questions? Well, thank you guys.
All right.